This is the second half of my video about trackers. In this video, we're going to look a little bit at Little Sound DJ and see how it actually works. So as I said last time, Little Sound DJ is a tracker program. That's a special type of musical sequencer that uses certain characteristic ways to represent music on screen. So you don't need to understand music notation in order to use a tracker, but you do need to know a little bit about music, and you need to understand the way that trackers tend to work. So number one, you'll see on the left-hand column that musical time is represented as a series of values in hexadecimal, from 0 all the way down through 9, and then A through F. So you have a total of 16 places in a hexadecimal system. The left-hand column represents increments of that. So the first 16 have 0 in the left-hand column. Starting with number 17, you've got 1 in the left-hand column. You kind of keep going up once you get past 32. 33 is going to have 2 in the left-hand column. It's a base 16 numbering system. I don't think it's coincidental that this is the system that the people who designed the sound chips for systems like the Game Boy, the Nintendo Entertainment System / Famicom used, because, as we discussed in the other video, 16 beats can be, or 16 time points, can be split into 4 beats, which can then further be subdivided into 4 16th notes. So you have this kind of hierarchical organization. 16 beats are grouped into 4, and then those are further subdivided into 4. The structure of a piece of music in Little Sound DJ is also structured that way. So you see in the bottom right of the LSDJ screen, you see these orange letters, or orange highlighted letters in a line, S, C, P, I, T. Then above and below the S, you have P and G. The way you navigate these is you hold the select button on the Game Boy or the USB controller or whatever you're using, and you can move left to right or up and down. So as you can see, if you move up, you see the project screen. This lets you set the tempo. It lets you set transposition if necessary. This is also where you see the song loading and saving area. Down below is groove. If you want to put a little bit of a swing on your LSDJ piece, you can mess with the percentage of swing there. But right here in the center is the song readout. Now the first 3 pages are sort of nested readouts here. What you have is each row here, the 0 row, the 0, 1, 0, 2, each row contains one value for each of the 4 tracks: pulse 1, pulse 2, the triangle wave, or the noise channel. Then within each of those, you have a chain, a series of up to 16 chains, as you can see. And then within those, you have phrases. So the structure of a song in LSDJ is sort of hierarchically nested. You're going to put actual notes in these phrases of 16 notes each. Then each phrase is held within a chain. So phrase number 0 would be a series of 16 notes. Phrase number 1 would be another series of 16 notes. Phrase number 2 would be another series of 16 notes. And you could fill this page with up to 16 values. And if we move back, we realize that would only be the very first value of the song. So the lowest level is a phrase. Phrases are contained in lines on a chain. Chains are contained in lines on a song. So it's hierarchically nested in this way. What we want to do is hit A to create a chain in here, hold select, go right, create a phrase, hold select one more time, and now we can start putting in notes. So how do we actually put music into Little Sound DJ? So we're at the level of the phrase, where we can edit the 16 notes that make up a phrase. What you do is you can select any of these lines, and I'm going to press the A button, and it's going to put a note in. So as long as I hold the A button, it'll play the note for me, or I can let it up. So C2 is the lowest note that the Game Boy can play, or that LSDJ can play. But each of these note spots could get its own pitch. We can sort of go upwards like that. And if I hit start, I can play what I have. So you can sort of hear, I hit start again to stop it. Once you hit start, it's going to loop through the phrase, and it's going to play everything you've written over and over again. And you'll notice that the notes, unless I tell them not to, are going to sustain infinitely. That's another control, which we'll look at in just a minute, where you can set the maximum duration for the notes. So if I want to get rid of some of these, I have to go to it, hold B, and then tap A. And that sort of undoes, what the A button does, adding a note. And what I'm going to do just to demonstrate this is I'm going to put a little bit of a famous piece of classical music on here so that we can hear how the sound works. So I'm going to hold A here, tap to the right to turn that into E, and this one becomes G. That's what we need for C, then E. So this particular piece, which is going to be Bach's C major prelude from the first book of the Well-Tempered Clavier. We're going to repeat the last 3 notes of this little bit. So I need C3 and then E3. So that's going to sound like this. So what I've just encoded is the opening couple of notes of Bach's C major prelude. But in order to make this sound like a piece of music, there's a little bit more work left to do. So at this tempo, I've sort of used every other slot in Little Sound DJ because I think that's a nice moderate tempo for this piece of music to be at. But what I've just programmed in is only actually half a measure of Bach's music. So the way we're going to deal with that is we're going to use the recursive nature of LSDJ, the recursive nature, the recursive way in which pieces of music are put together in this program. So this has been the level of a phrase, and we've just filled the phrase up with music. So what I'm going to do is hold select, go back to the left. You see that in my chain, phrase 0 has that. So if I were to play the chain, it's going to do the same thing right now. It's just going to repeat on an infinite loop that little bit of music that I programmed in. So what I actually want to do if I want to recreate Bach's C major prelude is I want to create another phrase, or I want to tell the chain to include another phrase. And if I tell it to include phrase 0 again, that's going to then play this music I just programmed twice. So you'll hear the same exact thing, but you'll see on the cursor that it's going to play the first version of phrase 0, then it's going to play the second version of phrase 0. See, first one, second one. Back to the first. Together, though, those create the sort of amount of music that Bach actually wrote in one measure. Then the C major prelude changes pitch, so what I need to do is create a second phrase. Now if I've highlighted my 0-1 phrase, I can hold select, go to the right, and I have a blank slate again. So I'm going to go ahead and program in the second measure of the Well-Tempered Clavier's C major prelude. So I'll use A here. And remember, it puts me back on the same note that I used previously, so I have to go all the way down to C. Then the chord changes, so we're going to use the same pattern of rhythms. but the notes are slightly different. We're going to outline a 2-4-2 chord for those of you keeping track at home. Repeat the last 3 notes of the pattern. So if I hit start, we'll hear the second measure, or really half of the second measure, on a loop. So that sounds right to me. I'm going to hold select, go back to the left. So since we need 2 phrases to equal 1 measure, I'm going to go down to line 3 here, hit A, and add a second version of this. So now when I hit start, it's going to first play phrase 0-0 twice, and then it will play phrase 0-1 twice. And that should give us the full music of the first 2 measures of the C major prelude. So we can start to see how assembling a piece of music, it works a little bit like programming. You kind of have to think of each individual phrase as a variable. I've created this variable, this little container of data, that I've called phrase 0-0. Then, separately, I've created a different container of data called 0-1, a different variable. That's got a slightly different set of notes inside it. And all I need to do to assemble a piece of music is to call those variables, to sort of stitch them together. Once I've created them in memory, I can add them in as many times as I want. You know, I can fill this piece of music and let it play for a long time. I can go back and I can totally fill this chain with as many phrases as I need. You know, each chain can hold up to 16 phrases. Then when we go back to the level of the song, one song can hold up to 16 different chains. So if you've got, 16 chains, each of those 16 chains has up to 16 phrases. That's 16 times 16, what is that, 256 different individual phrases of music. So we can see how the structure of phrases allows us to create a song that has sort of whatever form we want it to have. You could fill a chain with different phrases in different orders, or you could go back to the beginning and say, here, my whole song might be put together out of, let's say 0-0 is the verse. Then you might add 0-1 is the chorus. Then you would want the verse again. Chorus again, 0-1. Then maybe you have a bridge back to the chorus, and then maybe some unique music for sort of the outro or the fade out or something like that. So your whole pop song might look like this if you look at it as a data structure. 0-0 is my verse, 0-1 is the chorus. I call those as many times as I need to. Then I have a contrasting bridge, 0-2, maybe a final ending section, 0-3. So it's a very computational way of looking at how a piece of music can be put together. I also think that it's interesting that as we hold select and go kind of left and right, we're almost navigating a little map. This sort of looks like the mini map you see in The Legend of Zelda or something like that. The menu, instead of being something you control with a mouse cursor and sort of click File, Edit, switch from page to page, you actually have to hold select and kind of navigate through the program. There are a couple of other features that I want to show. For example, you can create custom waveforms on Little Sound DJ by changing the position of these waves. Over here, you can control how the instrument itself works. So for example, the pulse instrument, the pulse wave, remember we call it pulse because it's not strictly a square wave. This one in particular is a square wave, but if I hold A, I can alter the value just like I can alter a note. And we can see this is a 12.5% on versus 87.5% off square wave has a different timbre than the 25% square wave, different timbre than the 50% square wave, and then the 75% square wave has the same timbre as the 25% square wave. You can change the length of a note if you want to make all of your notes short. You can have a maximum value here. 3E, that's a lot in hexadecimal. You can go all the way down to a much, much lower value if I want to have a whole bunch of short clipped notes. And that's going to stop the note from sounding forever. You have to put a higher value on these, otherwise once you activate a note, it will simply play until you activate the next note. You can put a couple of different effects on this: sweep, vibrato. You can enable transposition. Finally, tables are used as another way to store data. You can then call them from elsewhere in the piece of music, quote unquote. So this is just a simple demonstration of how Little Sound DJ is put together. I showed you in the phrase how you can put individual notes together. Then in the chain, how you might repeat those sequences of notes, or how you might go on to new sequences of notes. So Little Sound DJ, it's a simple program. It takes a little bit of time to get used to the way it works, to get used to the way it puts music together. But as we saw in the Reformat the Planet documentary, it's very versatile. And it really, when Little Sound DJ came out in the year 2000, it really helped to start and launch the chiptune movement. It helped to let musicians experiment with Game Boys and kind of turn the Game Boy into a musical instrument. This is the reason also that you see the actual Game Boys frequently being used for live performance. Because this is a Game Boy game, essentially, it wasn't made by Nintendo, but it comes either on a cartridge or as an emulator. It doesn't have the sort of modern save export sort of features that a modern piece of sound software would have. So artists are left with either plugging a headphone jack into their actual Game Boy or doing some kind of a screen capture like I'm doing here in order to actually get their music out of Little Sound DJ, or you could play live off of your computer. So it kind of requires some workarounds to get the music to work, but it's a very flexible and interesting way of looking at music.